Hello everyone. Welcome to the Cybersecurity course. I am Dr. Rashmi Sahai, the course coordinator, and I am excited to guide you through this important and timely subject. This course is offered under Faculty of Science and Technology, ICFI Foundation for Higher Education, Hyderabad, a reputed institute dedicated to quality technical education and industry-relevant learning. Cybersecurity encompasses industries and domains where data protection, secure software development, and threat mitigation are critical. Specifically, this course aligns with functions in industries like cybersecurity services and consulting, software and application security, network security and infrastructure management, defense and critical infrastructure, cybersecurity. The primary objective of this course is to make learners aware with comprehensive understanding of cybersecurity principles, tools, and techniques. You will learn how to identify security threats, protect system from attack, and apply best practices for designing secure applications and networks. The course is designed to equip you with both theoretical knowledge and hands-on skills essential for today's digital security landscape. The course has 5 modules. The first module is Introduction to Cybersecurity and the Evolving Threat Landscape. This module introduces the fundamental principles of cybersecurity, establishing why securing digital assets is critical in today's interconnected world. It covers the CIA triad of confidentiality, integrity, and availability, the motives behind cyber attacks, and the attacker lifecycle. It provides a practical understanding of how adversaries identify, exploit, and maintain access to systems. Students will examine real-world data breaches to appreciate the scale and sophistication of threats. Key emphasis is placed on securing system, the role of compliance framework in defending modern-day attacks. Key topics which will be covered in this module are cyber threat taxonomy, security objective and risk model, attacker motivation and methods, mega breaches, designing secure system, organizational security and compliance initiative. The next module is fundamentals of cryptography. This module explores the mathematical and algorithmic foundations that underpin digital security. Starting with symmetric encryption techniques, the module progresses into asymmetric encryption, digital signatures, and key exchange mechanism. Student will understand how cryptographic primitives support secure communication and authentication protocols, and will learn to distinguish between theoretical design and practical applications with hands-on use of real-world tools such as transport layer security. Key topics that will be covered in this module are block and stream ciphers, one-time pads and authentication schemes, public key cryptography like RSA, ECC, key exchange protocol, transport layer security, hypertext transport layer protocol security, and secure messaging, cryptographic failures and implementation risk. Identification protocol and secure communication is the third module. This module focuses on verification of identity and establishing trust in communication. Students learn how to implement and analyze authentication mechanisms like password, token, multi-factor authentication, how to protect against replay, eavesdropping, and man-in-the-middle attack, and how to use challenge response protocol for stronger security. The emphasis is on building secure authentication workflow and understanding vulnerabilities that arises from poor identity management. Key topics that will be covered under this module are user authentication methods, identification protocols, multi-factor authentication, challenge response mechanism, communication protocol vulnerabilities, and best practices for securing login systems. The fourth module is secure coding practices and software vulnerabilities. In this modules, the learner will be empowered to write secure code and recognize common programming flaws that lead to vulnerabilities. Using a combination of theory and lab-based exploration, students will discover how attackers exploit buffer overflow, use after free bugs, and format string vulnerabilities. Techniques such as static code analysis, dynamic testing, and fuzzing are introduced for vulnerability discovery and redemption. Additionally, the security implications of different programming languages and the role of languages in base security are explored. Key topics are common coding flaws and memory safety issues, buffer overflow, heap exploitation and code injection, static versus dynamic code analysis, fuzzing techniques, secure programming principles, and language-based security. Now, in the next module, which is ethical hacking and system isolation techniques, students will be introduced to tools and mindset of an ethical hacker. They will perform controlled exploitation exercises in a virtual lab environment, simulating reconnaissance, vulnerability scanning, and privilege escalation. The module also emphasizes defensive containment strategies and such as sandboxing, system call interposition, and virtual machine isolation. These techniques are crucial for limiting the radius of any security breach and are increasingly adopted in modern cloud and container-based infrastructure. The key topics which will be covered under this module are principles of ethical hacking, penetration testing lifecycle, scanning and exploitation, system isolation and sandboxing, virtualization for security, post-exploitation mitigation strategy. Each module in this course focuses on a key aspect of cybersecurity and incorporates interactive activities such as quizzes, case studies, and simulations, and labs to ensure active engagement and practical learning. In this course, we will explore the motivation behind cyber attacks, attack landscape, life cycles, and prevention techniques. This course is suitable for students of third year and final year of engineering who have a basic understanding of operating systems, computer networks, and programming fundamentals. However, no prior knowledge of cybersecurity is required. Upon the completion of this course, the learner will have the understanding of core cybersecurity concepts and terminologies, identification and analysis of cyber threats and vulnerabilities, implementing capability uh, of secure authentication and cryptographic solutions, application of secure coding practices and use of security testing tools, ability to conduct ethical hacking exercises and recommend hardening techniques. The course duration is 13 weeks, structured for flexible, self-paced learning. This learner will earn 3 credits upon the completion of this course. The grading scheme will comprise of internal assessments and activities and proctored examination. Assignments will reinforce learning through practical application, while the end term exam will assess overall comprehension across all the modules. This course aligns with the National Cybersecurity Resource Framework to the level of 5.5, ensuring that the skills acquired by the learner meet national standards of cybersecurity competencies. Additionally, the curriculum also incorporates latest cybersecurity practices tools, making it highly relevant for career in IT security, network administration, ethical hacking, and related fields. We are committed to supporting you throughout this journey and encourage active participation in all activities. Together, let's build your cybersecurity expertise and prepare you for the challenges of securing the digital world. Thank you and welcome aboard.